uh, to the next company, and the company is called RECYCLEKARO, and I'm very pleased to welcome Parth from this company presenting, and they are tackling the really important topic of recycling. Almost in every session we have so far, there is some company with some innovation, some idea of how to make this recycling process possible. And I think that shows the importance of this whole market area. So, Parth, you can already share your screen, and remember you have 4 minutes to present your idea, and then
Sure.
4 more minutes for questions. So the floor is yours.
Could you see my screen? Can you see my screen?
Yes, I can see it, but it's not in the presentation mode.
Sure. Just give me a second. Is it visible now in full screen?
Now it is visible.
So hello everyone. I'm Parth, and with me we have Mr. Prasan, who's the CEO of RECYCLEKARO. And basically, just to give an overview, we are a lithium-ion battery and an e-waste recycling company based from India in Maharashtra. So we are a 14-year-old company, and we have entered the recycling business 14 years back. We started with 1 year of paper recycling, and then we shifted to e-waste recycling and lithium-ion battery recycling. The current capacity that we are running at is 10,000 metric tons of lithium-ion battery recycling and 24,000 metric tons of e-waste recycling annually. So these are some of our innovations. We have created a technology through which we have created an in-house technology through which we extract all of these precious metals from the batteries like lithium, cobalt, manganese, nickel at a purity of 99.5% plus, and the extraction rate for the same is 95% plus. And we have even filed 2 patents regarding extraction of lithium from batteries. And the plant is located of 90 kilometers from the Mumbai airport. It is in Wadha, Palghar. So that is a bit about us. And these are some of the products that we can recycle. So basically, when we talk about e-waste, anything that consists of PCB inside it, it is considered as an e-waste. And we have the technology to recycle extensively all kind of batteries available in the market today. So these are some of the metals that we recover from e-waste and lithium-ion battery, both of them. And all of these metals are some of them are from the PGM group, and some of them are even like daily used, like aluminium, iron, and all of these metals. We even have the technology to recover palladium and platinum from different sources and different e-waste kind of things. And it is a workforce. We have 300 workers, and the factory is spread across 18 acres of land. And basically, we provide lithium and battery recycling services to all of these OEMs based in India. One of our biggest customers, some of our biggest customers are Tata Motors, Bajaj, and Ather, and all of these EV companies through which we have a contract and we buy batteries from them, and we recycle them, and all of these metals are sold into the market again. And all of these metals are industrial grade metals, so they can be used in the future. They can be used again into the manufacturing of cells in India. As you might be aware, a lot of companies are opening cell manufacturing companies in India, factories in India. So this is a bit about us. This is a bit of a process that how is the process like with the OEMs, and how do we take it further? And basically, we use the technology of hydrometallurgy, and there are only 4 companies in India, those who have the technology to recover all of these precious metals from the black mass. Black mass is basically a powder which consists of nickel, cobalt, copper, and lithium. So that is a bit about us.
Perfect.
So
Thank you
yeah,
very much, and perfectly on time. So we have enough space for some questions. Are there any
sure.
questions from the audience who want to come forward? Just write them in the chat or unmute your microphone and ask the question. Otherwise, I will start with one. Parth, what are the future innovations you are looking for to develop? And maybe also for these innovations, what partners would you need?
So the future innovation that we look forward is battery as a segment. It is a rapidly growing and rapidly evolving industry. We see every day there's a new kind of chemistry coming up in the industry. So the innovation is an unstoppable process for us. So basically, whenever there is a new kind of battery innovated in the industry, we need to be be efficient enough to develop the technology as soon as possible so that we have the capability to recycle the new chemistry batteries in the market. That is one of the factors that would change us.
Thanks a lot. Maybe a follow-up question, which is interests me in general. How do you see if a new battery technology comes, a battery chemistry like sodium batteries in general? Like,
Yeah.
what is the impact you expect on the recycling market, since sodium is so much cheaper than lithium?
I would like to comment here. Yes, the sodium type of battery will be much cheaper compared to what lithium-ion batteries are there. But as per the utilization of these batteries, because the end use will not completely replace lithium-ion batteries. Because of the weight of the sodium-ion batteries, they might go into energy storage devices. They might not be used fully into EV vehicles, or might be used for the vehicles or for logistics or some other like applications, but they will not completely replace lithium-ion batteries. Lithium-ion batteries will be there. And in case of recycling industry, like what we do is we have a hydrometallurgy plant where we are recycling all type of lithium-ion battery chemistries. Even if the sodium-ion battery comes for recycling, we have a kitchen ready to recycle for that. So we have a setup ready where we can recycle the sodium-ion batteries also within our plant. So recycling is possible, as well as these all chemistries are, as of today also, there are different chemistries in lithium-ion batteries like LCO, LTO, then NMC, LFP. So every chemistry has their different applications. Few are effective in drones, few are effective in portable devices, few are effective in EV vehicles. So these will be co-sharing the space which we assume.
It's good to hear. So the business case is secure. There's a question from the audience. Daniel Seidel wants to know if the whole recycling process you are doing is a dry process.
Is it a pardon?
Is a dry process? So you know the difference.
Yeah, so the shredding part is the dry process, but after shredding the batteries or the black mass, that black mass goes through the hydrometallurgy process, which is water and chemical based. And our plant is zero discharge plant, because at the end of the day, when you recycle everything, extract all the metals, there is a lot of water generated. So this water we process using a multi-effect evaporator plant, where water is evaporated, condensed, and used back into the system. So no water discharge goes out, while the byproduct is sodium sulfate, which is again sellable in the market.
All right. Daniel, I hope that answered your question. Otherwise, just speak up with a follow-up question. And I think we have time for a last question. Puneet is asking, is there a good ecosystem for enough end-of-life batteries to be collected for recycling?
Yes, there is because till last year our capacity was 4,200 metric ton, which we have increased to 10,000 metric ton this year, while our plant was almost 95% utilized last year. And we see a lot of lithium-ion battery scrap getting generated, because they are there in the market since last 5 to 7 years. We have also started looking at the EV motor scrap, EV batteries coming up for recycling, especially two-wheelers and three-wheelers are in a large quantity. while there are a lot of lithium-ion batteries which are used in the network towers and all. So we have collected around in one go 350 metric ton of batteries or 700 metric ton of batteries. That kind of huge quantity is available already.
Thank you very much. And I think the last question in the chat is a really short one, so let's squeeze it in because it's, I think, a yes or no question. Do you also consider recycling the graphite?
Yes. So we are developing a process to create graphene out of the graphite. Like pure graphite, we are already working on that. And the next stage will be to create graphene out of that.
Perfect. Thank you very much. And with that, we switch over to the next